Hello everyone, my name is Akshata Rajigre and the topic for today's presentation is boosting. So boosting is one of the most powerful in-stable learning method used in machine learning. In this session, we will cover why boosting is important, what is boosting, how it works, how it is useful to us, its limitation, and in the end, a short summary about boosting. So let's get started. Firstly, we will see why boosting. In machine learning, sometimes a single weak learner model is not enough to make accurate prediction. For example, a single decision stem, which is one level decision tree, might perform poorly. But boosting solves this problem by combining multiple weak learners together to get accurate results. The key idea is that each model corrects the mistake made by the previous model. For example, think of a teacher helping a student. After each test, the teacher focuses on the mistakes made by the student. Over time, the student improves across all the subjects. That's exactly how boosting improves the model step by step. It focuses on the mistakes made by the previous learner and improve it to the next learner. So now we will see what exactly is boosting. So boosting is an in-stable learning method. It builds model sequentially, one after another. Each new model pays attention to the data points that were misclassified earlier. The final model is weighted combination of all the learners where all models contribute more weight. For example, a real life example. Suppose you are preparing for an exam. In the first test, you make mistakes in algebra. In the next study session, you focuses more on algebra. In the second test, you make mistakes in geometry. So you practice geometry more. By repeatedly correcting mistakes, you become strong in all the topics. That is exactly what boosting does. It keeps focusing on the errors until the overall model is trend or the overall model becomes strong. So now we will see how boosting works. Now let's talk about how boosting works. The process is simple but also powerful. The first step is start with equal weights for all the data points. We will need to assign the equal weights for all the data points present in the model. The second step is train a weak learner, such as small decision tree. Firstly, we will need to train a weak learner. For example, small decision tree. Later, we need to like step three is we need to increase the weights of the misclassified point. We need to increase the weights. Then step four is train the next learner. Like we will train the next learner. We will give him more weights or we will focus on the mistakes made by the previous model and improve the our next model. Lastly, we combine all the learners using weighted voting or averaging. For example, there are three students, two of them saying that this is cat and one is saying this is dog. In this case, we will use the weighted voting system and we will consider the answer of or the prediction made by the two students. Like that, in the end, the final model is more accurate than any single weak learner. So now we will see the limitations of boosting. Of course, boosting also has limitations. Firstly, it is computationally expensive. Training takes longer since learners are built sequentially. Second, it can overfit the data. If the number of learners is too high or the parameters are not turned correctly, it will overfit the data. Thirdly, boosting is sensitive to outliers. If there are unusual or noisy data, the algorithm may spend too much effort trying to classify them correctly, which can harm overall performance of our model. For example, we will take one example, spam email detection. Suppose we are having weak learners which will perform individually and give us poor performance. For this we will or for this boosting will combine all the models and uh, and take their final outputs and make the strong decision in the end. When at the end we will get to know that whether the email is spam or not. There are some real world applications of boosting also. We will use boosting is medical diagnosis for identifying disease from patient data. Secondly, fraud detection for spotting unusual transaction partners. And we will use boosting in recommendation system such as Netflix and Amazon. To summarize today's session, boosting is an ensemble learning method that combines multiple weak learners to form a strong learner. It works by focusing on mistakes at each step, improving accurate sequentially. It is highly effective for both classification and regression problem, but it requires more computation, careful parameter tuning, and can be sensitive to outliers. Overall, boosting is a cornerstone of modern machine learning, accurate, powerful, and widely applied in real world problems. Thank you.